Oh, hello everyone. My name is Akshay and welcome to this GFG POTD streak of day 83. So if you are new to this channel, please like, share and subscribe so that I also got motivated to make the new video for you guys tomorrow ahead. So let's start the question. So the question is saying, today is the category of the question is easy and the question name is minimize the sum. So you are given an elements. You can remove any two elements from the list, note their sum and add the sum to the list. Repeat these steps while there is more than a single element in the list. Okay, the task is to minimize the sum of this of these chosen sums. So for n equals to 4, they are given as merge the first two elements 1 and 4 that sum up to 5 and push 5 as the new element to the new list, that is 5, 7 and 10 is the new list. Then again they merge the first two elements 5 and 7, so that gives us 12. So the answer becomes the previous sum, that was 5 plus 5 plus 7 12 17, and the new list is 12 comma 10. And again, since there are more than one element in in this list, so the previous answer was 17 plus the addition of these last two elements, it's 39. And now the new element present in our list is 22. That goes a single element. So as said by the question, we have to stop because there's a single element in the list and the total answer is 39. Similarly, we have test case 2 with this array 1 3 7 5 6 and the output is 48. We have to drive in for this thing to get help, that how we should proceed on with the pseudocode and the code. So let's read the further information that the task is to complete the function minimize sum, which takes n as the size of array. It has to minimize the sum to some, okay, to the same constraint there. So the constraint is given as 10 power 5. So we have to discuss about this first. So the constraint here is 10 power 5. So what's the worst complexity that we can use to solve this question? Is for 10 power 5 we can use n root n. That's the worst, and we can use the other complexities that is lower than n root n, that is n log n, and so on. So if you're not getting this logic of 10 power 8, that how I am calculating this, then I made a video on this as the name of trick the TLE. It must be popping up here now. You can see that video now. So it's very important to know that how the 10 power 8 constraint works. So let's just jump to the question. Hmm. So the constraint given was 10 power 5. So the maximum I can use n root n, or I can use n log n on the below of n root n. So that is n, that is n root n, that is log n, and so on. And you can see that in the above three time complexities, the GFG has also mentioned the expected as n log n, right? So it holds the 10 power 8 logic in every question. Okay, so let's see. So this let's try to dry run the second test case as they have dry run in the first test case. So the elements were 1, 3, 7, 5, and 6. So they had a sorted array, right? 1, 4, 7, and 10. So let's just sort this also so that we do not get a different answer. Because why they have sorted, I guess, because we need to choose the minimum sum, right? Minimum sum. So minimum we can get while we have a plus b as sum, right? So to minimize this RHS, we have to minimize this LHS also, right? And so we have to choose the lowest a and b possible, lowest a comma b possible. And to choose lowest a comma b possible, the array should be sorted, right? 1, 4, 7, and 10. So the first a and b will be 1 comma 4. There is no other combination of a and b which will be less than this 1 comma 4. So that's the intuition behind it. So the first thing is that choose the two lowest possible numbers, lowest possible numbers. I can get this intuition from the dry run of the first test case. And let's see if we do not take this number as the lowest one, then if our answer changes or not. Let's say we have 1, 7, 4, and 10, right? So what I will do, 1 plus 7, that gives us 8, and our array becomes 8 comma 4 comma 10. Then 8 plus 4 becomes 12, so I will add here 8 plus 12, and our array becomes 12 comma 10. So it gives us 22. I will add 22 here. So that gives us 8 plus 12 plus 22. So that gives us 20 plus 22, that is 42. But the answer is 39. So it's proven, yeah. So first point holds true. Let's just try to dry run for this second test case. So once I've sorted it, it will look like this: 1, 3, 5, 6, and 7. So let's just consider the first two elements first as A and B. So it will be 4 plus the array will be like 4, 5, 6, and 7. And now 4 plus 5, that is 9. So I will add 9 here. It will be 9, 6, and 7. Now 9 plus 6, that gives us 13. So it is 13 comma 7. And then 13 plus 7, that gives us how much? Okay, 9 plus 6 is 15. So 15 here. And 15 plus 7, that gives us 22. So I'll add 22 here. So what's the sum here? So 15 plus 4, that is 19. 19 plus 9, it's 28. 28 plus 22. 28 plus 22, that gives us, wait, I'm facing some problem with my point. Okay, so 28 plus 22, that gives us, I guess, how much? mm, 50. 50, but our answer given is 48. So mm, we have to improvise something more in our code. So let's just make a quick look of the dry run we made. We did the same thing in the first test case, but where we are going wrong. So it's sorted 1, 3, 5, 6, 7. I took the first entry that the lowest possible is 1 comma 3. That is, no other possibility will be greater than, will be lower than 1 comma 3. So if I consider this thing 4, 5, 6, and 7, then it's again sorted. I can see. So the lowest will be 4 and 4. The first two elements, that is 4 and 5. No other possibility will be lower than the first two elements. So if I sort it again, so it will be 9. Okay, I got the loop. I got the loophole. So we have to sort. Whenever we are using the first two elements, we have to sum it, and the new elements that we obtained, we need to sort, because in this case, what I have chosen 9 comma 6. But I can say that if I would have chosen 6 comma 7, that will be the lowest possible for a comma b, that is contributing to the sum. So यहाँ से so let's just break the loop from here. So let's make a dry run again. Yeah, let's make a dry run again. So it will be 1, 3, 5, 6, and 7. So we combine the first two elements, that is the lowest possible. So it will be 4, 5, 6, and 7. And the answer is now 4 plus. Then I combine 4 plus 5. As you can see, it's sorted, and the lowest possible will be 4 comma 5. So I can see that 9, 6, and 7. So I added 4 plus 9, but you can see that 9, 6, 7 is not sorted here. So I need to sort each and every step. So the second point will be when I am removing a comma b and doing its sum, and when I'm passing this sum comma rest of elements, this is the new array, right? Sum comma the rest of the elements. So that should be sorted. Then only we can pull a comma b from the first two elements, right? So we sort it. So after sorting, it will be looking like 6 comma 7 comma 9, and I can take again the first two, the lowest possible numbers, that gives us 13, and the updated array will be 13 comma 9. Then I have to do the only two remaining elements, that is 13 plus 9, that gives us as how much? That gives us as 22, right? So I will plus 22 here, and if I sum this now, it will be 13 plus 4, 17. 17 plus 9, how much is that? 17 plus 9 is 26, I guess. 26. And plus 22, it will be 48. Okay, so I got my answer. So we have dry run it, and we come to the two intuition that we have to choose the two lowest possible numbers. And when we have chosen the two lowest possible numbers, so after doing the sum of that two lowest possible number, we have to push that sum into the rest of the elements, into the rest of these elements, to make a new list, and we have to sort that list again, right? So how can we do that? So if we make a new list and keep on sorting it, so what I can see, the time complexity will go to, I'm always removing two elements, right? So how much elements would I will removing? I will be removing n minus 1 times from the list of n elements, and I'll be sorting and again and again and again. So I'll be using n minus 1 into n log n. So if I remove the constant, it will be n into n log n. So if I will be able to code this solution, that is sorting the list again and again, I will get TLE for this thing, because 10 power 5 into 10 power 5 log 10 power 5 will be greater than 10 power 8. So it goes out of the bound of 10 power 8 and it will produce TLE. So we need to, since we have studied data structures, we need to think of something, a structure that may be helpful for us to reduce this complexity into let's say NlogN, or such that it should go in the lower bound of 10 power 8. So what I'm thinking is I need to maintain so let's go to constraint again. So I need to think something in NlogN, right? Because sorting is involved. So sorting every time does not make my job done, right? So let's get to our chart and what were the standard data structures that were involved using NlogN. So one was the tree map, NlogN, and this is heap, and this is sorting. So let's get back again to our paint. So sorting will not work. The brute sorting will not work. There is one more thing, that is tree map, and there is one more way of, that is priority queue, that is heap, right? So tree map, it will be like value, it's a pair, right? Key and value pair. So I don't need this second parameter because I don't need to maintain any count or something like that, right? So I don't think tree map will be a good option to proceed on. So let's think in the direction of heap. Can we do something about that? So heap is nothing but a structure which which what it uses the sorting order. By default, it sort all the elements in ascending order, right? So I think that should be our answer here. So if I just make a priority queue and push all these elements 1, 3, 7, 5, 6. Okay, let's run it again. So we have this element as 1, 3, 7, 5, and 6. Let's push it everything in the queue. So in the queue, if I push it, it will look like 1, 3, 5, 6, and 7 sorted order, right? Now what I will do, I have to take the first two elements, right? So I will do 2 times poll. So let's poll it and store the first poll as in A, and poll again and store the second poll as B. So this A will be pointing to 1, this B will be pointing to 3 here, and we will make the sum of 4, and we'll push it in the priority queue. So the priority queue will look like 4 comma 5 comma 6 comma 7, right? And we will just maintain our answer variable, and we will keep adding it with the sum. So the priority queue is now updated to 4 comma 5 comma 6 comma 7. Then again I will pull two elements out, I will do this sum, and will again push into the priority queue. So now the priority queue will look like 9, 6, and 7. But since it's the priority queue, it will be already in sorted order, right? So it will rearrange its element, and it will be arranged into 6 comma 7 comma 9. And I will again pull the two elements out, and I will push the sum, so it will be 9 comma 13, right? Not 13 comma 9, because since it is a priority queue. Okay, so I think the priority queue is our answer in this case. It holds true for every case here. So what should be a pseudocode now? So I will just run a for loop, and I will do pq dot add array of I, the all elements. This will be a step 1. Now step 2 will be when I have to stop the operation. I need to stop the operation when there is a single element left in the priority queue. So for that case, I can run a while loop, right? And the while loop will be saying that if pq dot size, if it is not equals to 1, then keep on running. And what we have to do in the keep on running stage, we need to poll 2 times, right? So let's just poll it. So I will write int a is equals to pq dot poll. So it will retrieve the first lowest element, and then I will say that int b is equals to pq dot poll again. So what it will do, it will retrieve the second lowest element. Now I will make the sum is equals to a plus b. And in the meantime, I will add into the answer. Answer plus is equals to sum, and then I need to push it again into the queue. So I will say pq dot add sum, and since this is priority queue, all the elements will be arranged in the ascending order by default. I hope you're getting this point. And at the last, I just have to say that return answer. I guess that's the pseudocode, and it will run for us. So this will be our step 2. Okay, so I have dry run it for you, the both the cases. I have shown you that how it differs from the first test case that was given the dry run by the GFG site, and in the second test case, what are the second what are the other parameters we need to include. So let's start the coding now. And one more thing, since we are using the priority queue, so what should be the time complexity here? It should not go out of bound. If it be going, then we will not proceed with the code ahead. So it will be, we are using a for loop, right? And we are pushing the elements. For the pushing removal, everything it took to log in time. So the first for loop will take nlogn. Then what I'm doing for, I'm pulling out two elements at a time until and unless the queue is empty. So I'm again using nlogn. From a pool of elements n, I'm pulling out two times, right? So it would be n into 2 log n, but if you remove the constant, it will be n log n plus n log n. So the overall time complexity will be n log n, and space complexity will be, since we use the priority queue for the n elements, it will be O of n. So okay, now let's get ahead with the code. Okay, so I need to make a priority queue, so let's make it. Let me just zoom into the question and remove this download bar. Okay, so priority QUEUE integer is PQ new. We have made the priority queue. Now the step one was to push all the elements in the priority queue. So I will say for n equals to 0, I less than n, I plus plus. And I will say pq.add array of I. So that goes as step one, to push, or to say to add all elements in pq, or let's say heap. And in heap, I will use MinHeap because I need to maintain in ascending order, right? So step two was, so till when we have to do the operation, until and unless pq.size is goes to 1. So when it is not equals to 1, I will do my operations. And what are the operations involved? That first we have to poll the two smallest possible elements, and since it is in descending order, the first two elements will be the lowest possible. So let's poll it. Int a is equals to pq.poll, and b is equals to pq.poll. So we have the, now we have the two lowest possible elements, right? And this implies we will get the lowest sum possible, right? Now let's make a new variable that is sum, and I will say a plus b. And what I have to do, I have to push it in the priority queue, and as well, let's just push it first. So pq.add sum, and after pushing it, we need to also add it in an answer, right? So answer plus equals to sum, and we need to declare our answer above. So I will say, since the return type is long, so I will use long for this answer variable. Long answer equals to 0. Finally, the answer will be answer plus equals to sum, and at last it will run until the priority queue has one element, and at last we just have to return the answer. So let's just compile and run. Okay, great. So your output expected output matches. So let's just hit the, now let's check it for the second test case, then we will hit the submit button. Why to waste our submission? So it was 5, 1, 3, 7, 5, and 6. We already did the dry run. It should come as we predicted, but let's see. So your output matches. Okay, so I'm damn sure now if I hit the submit button, it will get submitted, as you can see. Okay, so all the test cases passed successfully. So I don't think the, okay, but let me give you a code walkthrough and the summary. So while doing the second dry run of the second test case, we come to an intuition that every time when we are trying to pull the two lowest possible elements, the array should be sorted. The array or the list should be sorted. So there goes to the intuition point two, that uh, while I remain while I have to remove a and b, the sum comma the rest of the elements that makes the new list, it should be sorted. So if I try to sort again and again when I'm pulling two elements and returning the sum, it will be sorting n times. So it goes to the complexity n into n log n, right? Here. And if we just put the constraint 10 power 5, it will go beyond 10 power 8. And we do not code that solution because it gives us TLE. Although if we have coded that solution, it would be a more complex solution also, but it would have worked, but gives the TLE. It would have passed for some of the test cases, as we already do, always do in our videos. So we came to so we started thinking in respect of some data structures, and for this I took help from my chart. It's a very useful chart here. You must watch this video to get help with the structured data structures, the time complexity. So NlogN is taken by sorting by tree map and then priority queues. For the tree map, I was not able to get any intuition that how to use it. We don't need the key value pair for this problem. So I jumped into priority queue, I did the dry run, and we found that it always maintain the elements or the list of elements in ascending order if we use the min heap and max heap for the descending order. And I used that intuition and we wrote the pseudocode, and then we finally coded the solution and it ran. So the time complexity here is O of n log n, right? O of n log n plus n log n, but that's the overall complexity will be n log n, and the space complexity will be O of n. So that's it for the today's video. Let's meet in the next video of day 84. Till then, if you like my approach, my explanation, please like and subscribe. It will help me to make a new video for you guys tomorrow with my full energy. Till then, keep studying. And the last few things is that this is my DSA repository. You can start and fork to get help with the source code. And that's my Instagram channel I just made for you guys. You can connect to me 24 by 24 into 7 to get help for any doubts or for any guidance. Okay, so let's end this video. We'll meet in day 83. Till then, keep studying, take care, and keep solving.